Hello, everybody. We're about to begin, and you might be wondering why I'm a Russian-speaking guy standing in front of 100 Russian-speaking guys and talking to you in a foreign language. And there are a couple of reasons for that. First of all, we want to go global with ML trainings, and we want, as you all know, our community is called Open Data Science, and the key word is open. So we want to be open, we want to be transparent. We don't want to hear and see some comments on Kaggle on LinkedIn about ODS being closed and not for everybody. So we decided to host our ML trainings in English, at least partially, and to share all our videos and presentations with the world. And the second reason for that is it is really cool for speakers to have some videos in English. I had once a case when I had an interview, and the guy who was supposed to interview me, he saw a couple of my videos on YouTube. They were in Russian but had English subtitles, and that interview went really smoothly because he agreed with all I said on the video, and it's like, I didn't even had an interview. So it's really helpful to all of you to come here and present in English and to share your findings and your knowledge with the world. So for those of you who might have forgotten what ML trainings are, I will remind you. So first of all, it is an offline event. So we gather together mostly for networking. As we all know, most of the machine learning competitions are online events, but it's really nice to come and see people's faces. And I know that ML trainings understood it, I think, a couple of years ago, and then Kaggle Days understood it as well, and they started to host those offline events so people could actually see and talk to each other. And it is also an online event, so we have a live stream right now, which is broadcasted all over the world. The second thing about ML trainings, you will see here a lot of best performing machine learning competitors, winners of the competitions, and they will share all the experience and knowledge with you. But you will also see some new guys, and this is also important. One thing to note, this event is organized by the company Dataset. Some of you might never heard of this company, but it was founded by Alexey Natyokin, and I hope everybody knows this guy. He's a founder of ODS.ai. Dataset organizes all the major events in Russia, including DataFest and others, and also organizes competitions, Docker competitions, for example, with some famous ones with Sberbank. And also I want to thank ODS.ai community and mail group, which hosted us here today. One more update. As you might have remembered, we have a web page called mltrainings.ru, and it was recently updated. Now it has a lot of competitions, not only on Kaggle, but on other platforms as well. And there are two crucial updates there. So there are two buttons. One is called I want to be a speaker button. So if somebody won a competition and wants to share his knowledge with everybody, he might want to push this button and become a speaker. So everybody can do that, and I highly encourage you to do that. And also, as you might know, there are a lot of platforms with ML competitions out there. There are like Japanese platforms, Chinese, African, Russian, and so on. And that Dataset team cannot keep up with all those competitions. And I know there were numerous attempts when people were trying to maintain the list of all the competitions, and it is really hard for one person to do. So feel free to report on any competition you will find on the internet. I know it's very tempting if you found a competition with a really tiny leaderboard, and you might want to try and win this competition. but please like provide it to the community. It is worth doing that. And last but not least, ML trainings have a huge presence on social networks. We have a YouTube channel where our live stream is going on right now. We have a Facebook group, we have a Telegram channel, and a Vkontakte group. And also, you might know that we have a Slack channel, ML trainings _live. So this is all I wanted to present. And our first speaker today will be Ivan Sosin. Can you please? Yeah, let's give him warm applause. So Ivan is famous for his achievements in image competitions. He had several gold medals in team competition. He also had a silver medal in solo competition. So we were on a team on a recent landmark competition. It was a little bit controversial, but still nice competition. And I saw Ivan's code, and I think given all the achievements he had and given the code I saw, he might be the next Pavel Pleskov or Artur Kuzin. So once again, please welcome Ivan. He will present the next. And let me also remind you that all the questions will be in English as well. And after that, all the speeches will be in Russian.
Спасибо. Да. Hello, everyone. Can you hear me? Oh, it's okay. My name is Ivan Sosin, as it was mentioned. Today I'm going to share my knowledge and experience about Google Landmark Recognition competition. And I should say that it's my pleasure to be here and to share my knowledge and learn something from you as well. First of all, I'd like to thank my teammates, Pavel Pleskov, who was here a few moments ago, myself, and Kirill Brodt, who also helped us a lot. We finished at the 9th place with some decent results, and I think it's great for such kind of competition with a lot of data. So, competition overview. What if you have some images and of some temple or something like that, and you are going to and you'd like to understand more about it? So the idea is to classify it to the known landmark and search something about it, read it. So the goal of competition is just common classification. And it was a two-stage competition. Test set for the second stage was released a week before the end. It also has some sister competition, a Google Landmark Retrieval. So if you have some image of, for instance, a tower bridge, you'd like to get the most similar images of the same London Bridge. And it's really important because some solution of the first and second place use retrieval model to boost their score. So Dataset features about 4 million images and was about 500 gigs on your hard drive and about 200,000 classes. It's really huge for me, because as far as I know, some state-of-the-art papers for face recognition that features a lot of classes have at max about 30,000 or about 40. So data was really comprehensive, and there were, so if you have some landmark of one museum, the picture could be taken from the inside or from outside, and etc. And there was huge class imbalance. So some landmarks were overpopulated in dataset, and for some classes there were about one image or maybe two. So what about train? Some good examples like the Great Wall of China and some place from Russia, I don't know where is it. Some bad, strange examples from train. It's like flowers, animals, some guys, all this kind of painting, I don't know, some writing as well. And what about test? Test is really good. There were a lot of humans, art, this one my favorite, animals, and maybe about 1,000 out of 100,000 was real landmarks. So it was a really tough thing to clean your submission at the first thought. So to evaluate data, you need to predict class and its score, like a probability. Then this submission is sorted in descendant order by this confidence and probability, and then this metric is calculated. So PAI is precision at rank I, and relevance means if this class is correct or not. So just a simple example, this metric favors some right prediction with high confidence and penalize wrong prediction with high confidence, like this one. So you'd better to predict cat at higher confidence than at low. At low confidence, yes. So this is my dev box configuration. My dev box is called after Mark Antony, mighty Mark Antony, some Roman guy. So my dev box features two 2080 Ti, Threadripper 2950X, 64 gigs of RAM, 1 terabyte SSD. It really was important because dataset was, as I said, about 500 gigs. And I use PyTorch for my pipeline. So usually when you are working with some huge datasets, you are not going to train your model from scratch. You just use weights pre-trained on ImageNet and then fine-tune it on your data. On ODS Slack, Artem Palvilev advised to just guess that this competition is like a humpback whale identification competition, where you need to identify whales by their flukes. But it has much more images and classes. My team have achieved good results on this competition, so I decided why not to transfer the whole pipeline this time and add lots of steroids. So idea is simple. The main features of my pipeline is using of mixed precision, where you calculate gradients for your model in half precision and update your weights in full precision. So it speeds up convergence by 2 times with SERISNet 50. That was a main model for this competition. The main feature of my model was a cos-phase head. This head features some different laws from common cross entropy. So common cross entropy is calculated like that. And you can see that features are calculated like a dot product of weight vector and features from the layer below in neural network. And it can be represented like that. And if you normalize weight and features, you can get this kind of difference between this class weight and your features. And you remove variations in radial directions by L2 normalization, and resulting model learns features that are separated in angle space. And it was really crucial. So here there is a formula for normalized softmax. And if you add some constraint that difference between class centroid and this feature is really small, and in this case features from the same class should be close together and far away from the others. So there is some picture that illustrate this. So here is some normalized softmax, and this is a large margin cosine loss. So you see that this is class 1, and features are closer to the center, and there is some margin between different classes. This cost face head and cost face loss gave a huge benefit in well identification and in this competition as well. Also, I use SGDR for escaping from local minima. It's just simple technique for scheduling your learning rate during training. I add some label smoothing. The true label for each class is smoothed. So if this image is from class 1, it will have about 0.9 for this class and small numbers for every other class. I trained model with batch size about 64. This is efficient batch size because I use for accumulation. I do it usually because of some noise in data, just to accumulate more information in each batch upgrade. I use HGD with momentum. Sampling technique was weighted sampling with log weights. I used it because data was imbalance, and large margin loss with these parameters. I trained first my model on resolution about 2056. Then I increased this resolution up to 448. And I used heavy augmentations. I'm not sure that it was important, but it was from the well competition pipeline, so I decided to remain it. What problems I encountered? PyTorch data parallel and data distributed didn't work and fast my model. I'm not sure why it was so. Maybe because there were a lot of classes and last matrix multiplication, last matrix was heavy and it was due some synchronization problems. But still, each epoch lasts about 12 hours. It's not much, but it's difficult to iterate quickly in this case, and all training for the last model took 14 days. It was really huge, and it was tempting to just stop training and use something else. Raw prediction needs a lot of RAM, because 200,000 classes. So I used some map from NumPy. On the first stage, there was actually no correlation between local validation and leaderboard. It was sad because it was like you train your model and you was hoping for the best results, but you lose. It was because I didn't clean the data firstly, and noisy data, as I said. To clean dataset, I use to remove some indoor pictures. That the idea is that indoor pictures are not really correlated with landmark appearance. So I took places 365 dataset and make a classification that classify indoor, outdoor. In this case, I diminish dataset from 4 million to 3.6 million images, about 10%, and it boosted score. And to tackle the test noisiness in test, we developed some comprehensive submission cleaning. First of all, model from Kirill Brodt should predict the same class. Model trained on places 365 should not predict less than 2 indoors classes. On Kaggle forum, there was some Google Landmark detector. It also should predict that it is landmark and not. And some resolution feature that images with this kind of resolution are likely to be landmarks. This filtering helped a lot during the first stage, so we decided to maintain it for the second stage of this competition. And we got such results. So you see, it's quite good with submission cleaning. And then I decided, why not after the competition completed, I decided to submit raw submission. And you can see something suspicious here. The score said that we should be on the 4th place. And that time I realized that I feel like this frog about several hours in the morning. Then I started to feel like that. And it was until the middle of the day when I was crying. But moving to the reflection, actually a single model that I trained was really good. It was better than other teams' single models. Metric learning, such as Cosface, is really good at this task, like landmark recognition. You should trust your local validation as much as you can, and never forget to test some null hypothesis for stage 2. I like to submit your raw submission. So let's go to the another places solutions. The place 1. They use some ResNet with generalized mean pooling. Actually, the recursive paper is here with L2 norm to build a descriptor. Also, they used open sourced model, a retrieval model from Kaggle forum. I think we should also do that, but still, what they done? They match every test image with train image and took the most common label from out of top 5, and they achieve quite good results. Then they do the same but keep top 20 and rescore it with the second model, and they got results better than ours. So, but using 2 models. After that, they decided that, so in our submission, top 500 is probably images from images that are landmarks, and top to 20,000 and above and below are images not from landmark. So why not we rescore this middle part with similarity to top 500, and they achieve safe top 800, and this boosts their score actually a lot. Then they repeat the same procedure for the model 2 or model 1, and they have top 520, and after that they merge these tops and achieve state of the art. Actually, it's really easy technique, and I'm slightly ashamed that we didn't come to that. The second place solution, they use huge ResNet 152 label smoothing as we do, but there was no metric learning at the recognition model, and they achieve not so decent result. But they decided to filter non-landmark with object detector. That was trained on open images v4. It's really huge data set, and to train your model on this data, you need a lot of time. So they split 600 object classes into different categories and filter their submission and have really good results, I think. After that, they decided to use the retrieval model, this huge monster with a lot of different models trained with arc margin. Arc margin is a sister technique to Cosface. So they decided to assign to each image some sort of class, like A1, that top 5 matched images should be is not more than 2, and the label is the confidence is high enough, and so on. So this, you can imagine this like most trustworthy, less and less, and they rescore the submission and got a good result. Then they decided to rescore it even more with another technique, that the predictor label between a retrieval model and classification model are the same, and got even a better result. And then they decided that if class is more frequent, that it should be rescored with a higher score. And this technique, just for nothing, you see that this kind of score and this one they got really good boost. The 8th place solution, he has nothing, it was a solo solution. He has nothing fancy, but also use arc margin, arc face, the synonyms, and contrastive loss. It's also a metric learning technique. And did everything obvious to rescore his submission with classification score on test. And another idea was that non-landmark images will have much more similar neighbors than non-landmarks. Than landmarks. It's like when in your submission some image has a lot of different similar images, it should be not landmark. So my favorite is kernel-only solution. You remember that a dataset is about 500 gigs, and this guy just decided, why not I download it, extract it in Kaggle kernel, train a model, and delete everything. And it's fine, he got a good result and finished in silver. And ultimate sacrifice. You know that in the last day, best known for his high scores and all money, he can't submit. And we suppose that Kaggle admins decided to sacrifice his medal and his money and let others to get that. So summary, Kaggle is pain, but no pain, no gain. Advices for the next year competition: use metric learning like cos-face, arc-face, and their combinations. Filter your submission with detector trained on OpenImage v5 that was released not long ago. Rescore your submission by second model. Rescore middle top based on similarity to top 200, and rescore based on class frequency. That's all. Thank you for your attention.
Thank you very much, Ivan. It's time for questions. Don't be shy. Ask questions. If you feel really uncomfortable with English, you can ask in Russian, and we'll translate. Do we have a mic for the audience?
Hello, thank you for a nice speech. And what was the final top 1 accuracy for a single image?
You mean for a single model or single?
For single model, yes.
Our late submission was the best solution for the single model.
I mean not the score.
You mean score accuracy?
Yeah.
We didn't measure it.
And by your side, by your eyes, how do you think?
By your eyes? I can say that on train set, the scores were 2 times as high, and F1 score was about 50%. For this huge number of classes, I think it's really good.
I see, thank you.
Any other questions?
Thank you for your talk. So I see a lot of top solutions are using these rules to filter images. And did anyone use second-level models to learn these rules instead of adjusting all these thresholds?
Actually not, I suppose, because it was difficult to make a good local validation. Or they didn't do that because they don't like to, because it was difficult to assess the number of real landmark in test set and to simulate it on local. But I think for the next year it will be a great advice. Thank you.
I hope there's going to be a next year competition.
Me too.
Any other questions? I have a small question about mixed precision. So how hard it is to convert your pipeline to mixed precision? How many lines of codes did you change?
Actually, not too much. maybe about 10 or 20, but I used NVIDIA Epix, and it's not really easy, but it's not hard to make it work, especially in single GPU mode. I also tried 2 GPU mode, but it didn't help me to boost the performance.
Okay, thank you for all the questions. We will have a small break about... we also had a nomination for the best question. And who will decide on the best question? Our speaker will decide.
I thank you for all your questions, but I think the second one was the best.
Which one was the second one? From Kostya?
Yes.
Okay, let's congratulate Kostya for the best question. Yeah, and so we have a small break, 10 or 15 minutes. Please go grab a coffee and come back.